Hello everyone. I am presenting here the chemistry lecture series in which one of the topic that is the acid base, and this is an introduction. So let's we have to start the presentation on the acids and bases. So the different theories are also related with the acids and bases. So what type of acids are possible and how we can give the concepts behind the acidity and the basicity of a solution or in the solid form, in the gaseous form. So all those can be related with the fundamental of the chemistry. Acids are generally those gives litmus papers into the acid, the uh, red. So red from the whatever the litmus paper and we are using, and when we dip it to the acid, so the paper color is changed into the reddish. So more reddish, then more will be the acidic, and that can be measured with the pH instrument, pH meter. So therefore, acids are related with the pH value from 0 to 7. Whereas the alkalis, or those are also called as the bases are related with the 7 to 14 pH. Here, the color changes, and in case of the bases, and that color change from the filter paper's color yellowish to the bluish. So if blue is more, then more will be the pH value, and more will be uh, the basicity basis. So strongness and strong and weak, though two different types of acids or whatever the bases. Acids and bases are separately, but when we mix with acid and base, then the a reaction occurs, and that reaction itself showing the product will be the salt and water. So salt and water is formed by reaction of acid and bases. Various examples are available. For example, if suppose we have the calcium hydroxide and sulfuric acid. So calcium hydroxide CaOH whole of 2 reacts with H2SO4. H2SO4, the sulfuric acid. Here, so that the product will be the calcium sulfate plus water. So water and calcium sulfate, that is the result of the calcium hydroxide and H2SO4. So here we can say uh, the questions are there that how such reactions occurs. That is because of the in acid hydrogen cations are there, in bases hydroxyl anions are there. So the combination of hydrogen cation with the hydroxyl anion and formation of the water. Water itself is the polar solvent, and so that is liberated. So that is the product of whatever A plus B is equal to C plus D. So A itself is the acid. Acid reacts with the bases, formation of the C. C itself is the salt, and D itself is the water. So this is the phenomena, very a great phenomena, where acids can be balanced with the bases. That is the process. What about the process? The neutralization. So any of acids can be neutralized with the help of the bases. Number of available examples in our life and in our body, that is also the present of the acid, and acids can be balanced with the alkalis, with the bases. Acidity in the acidity in stomachs. So that is the concern of the acid. Whatever that acid, because that is the human body is very complicated concern, and different humans uses different types of foods and different types of their living standards, living. So we have to see acid plus bases, then the salt, and then the water. If we suppose what we have, the salts very lots of example. We are also using the table salt, that is the sodium chloride. So sodium chloride, NaCl. NaCl is there, and if suppose sodium chloride undergo the process of the hydrolysis. Hydrolysis means the water is there, and hydrolysis concerned with the H positive generation and anions. So H positive, that is the proton, but that can be go towards the H3O protonium. Whatever the hydroxonium ion. So there is the whatever the H positive in the form of the H2O, H3O positive, hydroxonium, hydro, hydronium, H3O positive, as well as the hydroxyl anion. So H positive we have say, and hydroxyl anion. So what happen hydrolysis when we are using the salt? However, we concerned about the different types of salts we are using. All of you will know about the iodized salt, and one more is the potassium chloride salt is also used by human being. So as well as the rock salts are also. So basically, the fundamentally table salt is sodium chloride, which we are using. So undergo the process of the hydrolysis of sodium chloride, and this will produce the sodium hydroxide as well as the hydrochloric acid. So that is the hydrolysis of the sodium chloride. However, number of salts are available. What are the different salts? Calcium sulfate, calcium bicarbonate, magnesium sulfate, potassium chloride, sodium nitrate, potassium nitrate. Number of salts are there. So nitric acid, potassium nitrate, the hydrolysis of potassium nitrate will produce the nitric acid, and then potassium hydroxide. So we have to see the different interaction and what are the products are formed. So it is the challenge for us how to balance those acids and bases in our life also. So that is the concern of the buffering. So buffer lecture is my buffer lecture is in another video, so you can also see the buffer solutions, that is the also important concern. And here we are using the acid base and the introduction. So let's say we have to see the introduction, and here uh, the first of all we have the various, I have mentioned the different types of acids, different types of bases. Again, I can repeat here, the acids are the examples, the H2SO4, the sulfuric acid, nitric acid, HNO3, and their bonding itself is also correlates with those of, that is the nitric acid. One more thing is there, the nitrous acid. So nitrous acid HNO2, and therefore other acids related with the sulfur, that is the sulfuric acid. Sulfuric acid, then we have the sulfurous acid, H2SO3, H2SO4, the example of the acid. Then further, we have also H2SO5, carboxylic acid. Further, we can see the H2S2O7. So there is a very range of the sulfur, H2SO3, SO3. Then H2SO4, H2SO5, and then the H2S2O7 or sulfuric acid, H2S2O7. Then here the sulfurous acid. Sulfurous acid H2SO3, H2SO4, H2SO5, H2S2O7, and H2SO7. That is whatever that particular per sulfuric acid, and this one per sulfuric is also commonly known as the oleum. So how we can say that all are the acids a range of the sulfur acids, and commonly the sulfuric acid is also called as the tejab, and that is the gandak ka tejab. So gandak ka tejab sulfuric acid, this one is H2SO4. So in various technologies, various processes of the uh, processing, uh, sulfuric acid itself is used. How this we get the sulfuric acid? And that is because of the sulfur compounds. So sulfur compounds are responsible to give us sulfuric acid and its other derivatives, other acids. How we get? The simple process. You see the periodic table, oxygen is there, then below is the sulfur. So both have the similarity because of the same. Oxygen atomic number 8, and whatever the atomic number. Sulfur 16. 16 sulfur, the phosphorus, then we have the chlorine. So in between the phosphorus 15, the sulfur 16, and then the chlorine. So we can see the relations. Whatever there is also the phosphoric acids are also there. There is also the chloric, the per, one most is the hydrochloric acid that is related with the chlorine. So phosphorus, sulfur, and this one. Sulfur itself is majorly known us, and because that is known since long time, and this was earlier used by different processing phenomena, even in the jewelry. This can be used for the testing of the silver long and long ago. That particular how to we get the testing of the silver with the help of sulfuric acid. So whatever that the silver, then sulfuric acid. So we get the silver sulfate. So here, whatever the ancient technologies, and even we can say the chemicals are the mother of all the technologies, whatever in our life related with the different technology. Space research, even the food, agriculture, all are the related, the different engineering, all the engineerings are totally based on the chemicals. So chemicals are the in the form of the materials, in the form of other specific materials, is whatever that specific city is because of the chemicals, and we have to know about the foundation of the chemistry, because that has a great role in designing of the any of the material, and we are using whatever different chemical in materials we are using for our life sustainability. What are many of the role of the chemicals here? We have the role of the acids and bases in the life, in the one of the most important concern, that the cleaning. So in case of the toilet cleaning, we are using certain acids. What are those acids? Here the namak ka teja, hydrochloric acid, as well as the sulfuric acids are used. So, great role of the acids and bases in the life. Then certain bases are also there. The examples: alkali metal hydroxides, sodium hydroxide, NaOH, potassium hydroxide, calcium hydroxide. These are the various examples. So now, what are the basic theories behind the acid and bases? Fundamentally, we have concern about what are the which things, which reactions, which fundamentally we have to go, we have to dig which process, which theories are there, and different theories are given since the last century. And earlier, one of the theory was established by the Arrhenius, and Arrhenius gives a theory, Arrhenius theory of acid and bases. So that gives the hydrogen cation are the acids which produce the hydrogen cation, which, for example, hydrochloric acid, the H positive is produced. So H positive hydro or hydrogen cation. All of you know about the atomic structure. I have also one of the video, one or two videos are on the atomic structure. So in case of the atomic structure, we see the proton and neutrons and electron. Since the John Chadwick invented the neutron, so earlier were the protons and the electrons. So H positive is what? H positive is the proton because electron is removed. So therefore, Arrhenius given the concept that because of early concept was there of Arrhenius, and at that moment the atomic structure was not fully developed. So Arrhenius gives that the acids are those which gives the hydrogen cation. At that moment, that was not there that proton itself is there. Whereas in case of the bases or basic alkalis, the concept was given that those produce the hydroxyl. Hydroxyl. So hydroxyl and hydrogen cation. We have earlier discussed about how they form, how the salts hydrolyze and produce the different. So here the theories, three different theories are given the concept. The Arrhenius theory, second Bronsted-Lowry concept, that's whatever concept behind the acid and bases. Third one is the Lewis acid base concept. So Lewis acid base concept that is also represents whatever that one is the electron pair acceptor, electron pair donor. But now, at this issue, since last 30 years, one of the another concept was given, and that is the HSAB theory. So that is discussed in my another lecture presentation. So you can see my another lectures on HSAB, hard and soft acid base theory. So that is the fourth one. But we have to discuss first of all to understand there is the introduction part for the acids. So here and say Arrhenius, Bronsted Lowry, Lewis, and various example, and one is the pH value. pH value, this is the measurement of acidity and alkalinity, and the range from 0, 1 to 14. However, still there are certain other strong acids are also available. And all of you know about the hydrofluoric acid. So hydrofluoric acid, even HF, HF can dissolve all the gases. So hydrofluoric acid is kept in the polymer bottle. Why? So because hydrogen, hydrofluoric acid, whereas we can store the hydrochloric acid in the glass bottle. However, this is the main concept that all the chemicals are kept in the glass bottle. Whatever the color, maybe the amber color itself is used because of the solar sun radiations, attack of the sun. So hydrofluoric acid, this can dissolve the glasses because the silicon oxide that is present in the most of the glasses, and this can dissolve. So if suppose we have the glass bottle and hydrofluoric acid we can pour, so definitely within short period the glass bottle will be separated. So these are the miracles of the acids. Very strong acids are also available. However, I have given the example of the persulfuric acid. So in case of the persulfuric acid, continuously sulfur oxides are liberated. So these are the various example pH value that can also correlate with the water. So here the pH value starts. Now the acid basis, how we can explain that particular is the acid. An acid is a substance that releases hydrogen cation, aqueous solution. The concept is here the aqueous medium is given aqueous solvents. So solvents and solute, what we have to know about the solution, a problem solution, that is the solution. So in a solution, solute and solvents are present. So what we have, an acid is a substance that release hydrogen cation in an aqueous solution. Aqueous means the water. So various examples. So first of all, we take the hydrochloric acid. Hydrogen and chlorine is dissolved in water. So hydrochloric acid, here the compound separates into the chlorine ion and hydrogen. What is the name of the chlorine ion? What is the name of the hydrogen? So here we can mention hydrogen, hydrochloric acid, and that produce the Cl minus and H positive. So this is the concept behind the acid. So what happen when HCl is there and in aqueous, so this gives the hydrogen cation, and this one is the cause. That means that acid is there. So here I have given all of you the question. What is the name of the Cl minus? So chlorine ion, and the name of Cl minus is the chloride ion. So hydro, whatever that is relates with the hydrogen. So here when we say the HCl, HCl molecule, what is the name? Hydrochloric acid. Here I can mention that is the namak ka tejab. So the namak ka tejab itself is used in cleaning of the toilets or the cleaning of the house, because that is the acidic behavior. So namak ka tejab itself, how we get, what the process we get the hydrochloric acid. Here I can mention that hydrogen chloride. Hydrogen chloride gas is there. So what about hydrochloric acid and hydrogen chloride gas? So hydrogen chloride gas is passed into the water and then saturation. So that we get what will be the strength of that particular relates with the normality, the molarity, whatever those the strength uh, concentration units, the normality. So generally the strong, the concentrated hydrochloric acid having the 16N means that is the normality. All of you can see my lecture on the solution in which the various concentration units are mentioned. Normality, the concentration unit of a solution. The molarity as well as other units are mentioned and are discussed in another lecture of the solution. So all of you can see the solution chapter, solution lecture related with the normality, molarity. Those are the units of the concentration. So is here the concentrate hydrochloric acid itself is the 16N. The dilute hydrochloric acid, how we get? We can add the water, then simply that is diluted. So dilute hydrochloric acid having the 5N. When we compare with the sulfuric acid, so sulfuric acid having the 36N is 36 concentrate sulfuric acid having the 36 normal N, whereas the dilute sulfuric acid, those are present in our the laboratory, so that it is the 5N. So 5N, the dilute acids which are present in the laboratory in the dilute sulfuric acid, dilute hydrochloric acid, and concentrate sulfuric acid 36N strong. 16N, that is the hydrochloric acid. So let's HCl. So HCl, hydrogen chloride, is gas. Then this is passed pressurely to the water. We get the hydrochloric acid. So here, the meaning of the acid itself that is clearly indicates that H positive is given. Then the similarly, the example of the bases and base, we can say, and that can give aqueously and hydroxyl ion, anion, HOH minus. So hydroxyl groups to be there in the respective bases. So here alkali, whatever these are also called the alkalis. I think all of you are well known about the whole periodic table, in which the different elements are arranged groups wise, 18 groups from top to bottom, and then the period from the left to right. So here different periods, and all of you know about the alkali metals. The name itself is alkaline earth metal. So here the example of the alkaline earth metal: calcium hydroxide, magnesium hydroxide, as well as potassium hydroxide, rubidium hydroxide, sodium hydroxide, lithium hydroxide, barium hydroxide, number strontium hydroxide, strontium, barium. So all these are the alkaline nature, and the concept whatever we have given, the concept of hydrogen cation, here hydroxyl anions are given. So therefore, such compounds known as the bases. Now, so various example, even when we have to see the p block elements, they are aluminium. So aluminium itself is also whatever aluminium hydroxide. So we can say different number of alkali metals. Alkali metals are form their respective hydroxides, and those hydroxides are the bases. Here the strong and weak bases are also there. Ammonium hydroxide, that is the with the ammonium ammonia plus the then water, so NH4OH, ammonium hydroxide. So hydroxide ion, so that is ammonium hydroxide itself, are also the example of the here. There are number of alkalis are available, whatever all of you are well known about the soaps. So how soaps are manufactured? Here the sodium hydroxide, that is the caustic soda. So caustic soda in the oil. So oil and caustic soda, the formation of the semi-solid material, and those are the soaps. And soaps, whatever the different soaps available. So one of that is the sodium, and oil is itself, that is the sodium stearate. So sodium stearate form, and that is in the form of the semi-solid position, and we get the soaps. So soaps we are using for the cleaning of the clothes. So similarly, potassium hydroxide is also the example of the alkali that produce the hydroxyl anion in the solution. So here number of things are available, and applications are very great applications. The sabun with the soap. So soap itself is used for the washing and for the bathing. So we have the cleaning of our body with the help of the potassium hydroxide used, and then oil is here there. So oil plus the basis, the formation of the product, and those are the uh, soaps. So now we can say one of this one is the most important process, This is the neutralization. What happens when we have the acidity in our body? So acidity in our body because of the so many acidic materials we are using. So different acids. So acid is produced whatever that particular inside the body. So therefore we have to remove that particular gases or acid in the body, and whatever those can be, we have to use the alcohol. So there will be the neutralization process. I have earlier discussed sodium hydroxide, alkali, base. This reacts with hydrochloric acid. So that is the also phenomena of the cleaning of toilets, cleaning material, because the acids generally, whatever in case of the acids, the materials dissolve, the react in the form of. So now we have one of the most important phenomena, and that is the neutralization. Neutral means not acid, not acid. So how neutralization process occur? And that neutralization is because of the reaction of acid with bases. Here I can also mention one more thing is there, and that is the calcium hydroxide. So in case of the calcium hydroxide, two hydroxyl groups are there. So therefore, two hydroxyl groups are released in aqueous condition. BOH ball of 3, so that can produce the relevant ions. So similarly here, one more thing is there, H2SO4. Two H positives are related. So here we can say, so the number of hydrogen cations are more in case of the sulfuric acid, whereas in case of the hydrochloric acid, only one H positive is released. And acid reacts with how many bases? So that is the basicity of acids. And similarly, in case of the bases, the acidity of the bases. So here, how many number of? So here we have to see the neutralization reaction. In case of the neutralization, the process here, acids and bases neutralize each other. When an acid and base reacts with each other, the characteristic properties of both are destroyed, neither acid nor the bases. So that's whatever this process is called the neutralization, and in which case we can see the hydrochloric acid, and here the sodium hydroxide. All of you have to know that sodium hydroxide, this is hygroscopic, and this is the flax or in the tablets. So sodium hydroxide, the hydrochloric acid, both whatever when reactions there, so reactant and products are the sodium chloride and water. This process itself is called, you can see, all of you can see the hydrochloric acid here, and as well as the sodium hydroxide is here. Then the reaction occurs and sodium chloride, this is the well known, whatever the table salt, which we are using regularly in our food and in our diet, that is the sodium chloride and table salt or the namak, and there may be and water is formed. So these products A plus B gives us the C plus D, and the whole process is called the neutralization. I have earlier discussed about that there are three theories, the theories of acids and bases that identify, and so that's we have, that is the theories. And there are three theories which identify singular characteristics and defines whatever the common definition of acid base, that is the Arrhenius theory, for which the Swedish chemist. So this was given in the during the concept innovations, the ideas, and that ideas is in the 19th century. So at that moment, all of you know about the development of atomic structure, that was not clear at that moment, at the time of Arrhenius. So, Arrhenius, Swedish chemist, one of the great chemists, and who given the concept that who given the concept and the theory, that concept, that acids and bases, and for this purpose, uh, Swante Arrhenius got award. Award is which one? The one of the prestigious, most award of the world. That is the Nobel Prize in 1903. So I think at that moment the atomic structure was not clear. All of you know the development of atomic structure, where the Rutherford, J.J. Thomson, a great chemist, have doing and done their excellent experiments, the Marie Curie, the Pierre Curie, and then whatever we can say that different scientists, then the Bohr, Niels Bohr in 1913. So we back to the there was no clear concept about the is there any possibility of finding subparticles in an atom. So that was not at that moment, because the concept of hydrogen, that theory was given by Niels Bohr in 1913, and James Chadwick invented in 1932 the neutron. So electron, proton. So what about the hydrogen positive? So H positive. So that is the hydrogen cation. So here hydrogen cation, that was given by the RNA. No, that but there, but the at that moment, what is the situation of hydrogen cation at that great chemist Arrhenius gives, and he got the Nobel Prize later on in 1923 because of the some changes, which one is the acid and how they react with each other. Whatever one acid react with the base, and then the chemical equilibrium attend, and then the conjugate acids and bases are formed. So that is the Lewis Bronsted Lowry concept, and that is the proton donor theory. The meaning of the proton donor. So I suppose at 1923 the development of atomic structure was more and more. So that was the clear. So therefore Bronsted Lowry theory, the conjugation of acid and bases, as well as they give us proton. So proton word is coming here, and here in case of the Arrhenius, only hydrogen cation was there. So let's we have to see the various development, and then the electron pair, Lewis acid. So that was later on, and here the electron deficient and electron rich compounds are there. So those are the electron Lewis acid base theory. Let's we have to continue the theories, Arrhenius and these different theories. Bronsted electrode theory, the H positive, and in case of the Lewis, that is the electron pair. Electron pair acceptor, electron pair donor. So that is the electron pair donor and electron pair acceptor. So later on, the Bronsted theory doesn't go against the Arrhenius theory in any way. It just added to it. Hydroxide ion are still bases because they accept hydrogen ion from acids and from the an acid produces hydrogen ion in solution because it reacts with the water molecule to giving the proton. Here also the name proton itself is given. So here the Bronsted-Lowry theory, that is the conjugate, the pairing of that. So what happened when water, this removes the hydrogen cation, whatever we have seen in the early this one. So hydrogen cation, the proton itself is given. So here hydrogen, so acid, and that become hydroxyl anion become the conjugate base. So in case of ammonia, this is the base, when it accepts the hydrogen proton. So hydrogen, uh, proton are given. That is the acid Bl acid, and in case of ammonia, that is the Bl. So conjugate as where, so there is the conjugation between those H2O and H3. So we can see the picture, and that is the Bronsted-Lowry theory. So here the picture, H2O liquid and H3 in aqueous form, base and the hydroxyl anion, that is AQ, stand for the water. So that is the medium, and conjugate base. Here the conjugate acid is formed. So this concept was the whatever this one acid base introduction. Then the significance. See, this is the very significance, and all of you know about the different reagent bottles. Here we can do the experiment with the acid base titration. So here all of you will know about that different acids are there. So here the question is there, how acid base titrations are done, that those processes are the neutralization. So here the methyl red. So different concepts, whatever the titration in that particular case, can do the different experiments. So it is a very challenging work to do the experiments with the chemicals, and we get definite answer for any of the problem related with the human being with the help of the chemicals. So acid base. Here one more thing is there, and that is the I have earlier discussed the acid base values, and that is in the form of the whatever I have discussed about the litmus paper. So here the parameter one of the acidity and which one. So that particular is correlated with there the range. So increasing acidity from the 6, 5, 4, 3, 2. So here is the baseline for that, and increasing alkaline. And here we can also see if sulfuric acid, that is the strong acid, the weak acid, and the weak acid having the range of the 4 and 5. So here are the, for example, acetic acid itself is about the 4, the 5, the range, so that acetic acid is weak. So that will be discussed on later on the whatever the salt hydrolysis regarding should more explain if suppose sodium chloride undergo the process of the hydrolysis, if sodium acetate. So sodium acetate is the example of the salt, but here we can put the weak acid, strong acid. So which are the weak acid? Weak acids are those where the dissociation during that molecule and the hydrogen cations are less produced, whereas in case of the strong, where the 100%, even percentage, 100% dissociation. Case of the hydrochloric acid, hydrogen plus and Cl minus are produced. But in case of the acetic acid, CH3COH, their hydrogen cations are less in number. So therefore, these are the weak. Similar aspect regarding the bases. So here are the some of the questions. What is the value of the ionic product of water? However, this is the content. So here 7 into 10 raised to power minus 14 moles the per square liter. So the ionic product, this can be explained. However, this is the significant questions. So here explanation: ionic product is the product of the concentration of hydronium ion and hydroxyl ion. Whatever the hydrogen cation is changed into the name of hydronium ion. In a pure water, this remains constant at a particular temperature. This is the value. Another ionization constant, because we can say that it's the effect of the conditions. So temperature condition, the ionization itself is increased. Another example, the pH is the negative logarithm of hydrogen ion concentration. So the pH in term of concentration of hydrogen ion. So therefore, the hydrogen ion concentration, that is the negative logarithm of, so pH itself is the negative logarithm of hydrogen. So that is the correct answer itself is the So now you can say we can take lots of information regarding the acid base, uh, where the fundamental issues, where the theoretical issues. So different aspects we can get the information from the different knowledge, and the great value addition was given by the three different theories, and even one in recent whatever the about 3 to 4 decades, that is the HSAB concept is also there, and that is the soft hardness and the softness of those acids, which gives the hard, which gives the whatever the cleaning technologies that relates with the hard acids hard. So HSAB theory, this is the new concept, and here we mention the general. So that will be HSAB theory. I have the that presentation, that lecture, that video lecture is also available. You can see the YouTube channel of Suresh Gyan Vihar University, where the we get that particular informations. So here the neutralization reaction, whatever I have mentioned, and that is the product will be the salt. One more thing is there. If we have the sodium chloride, if we have the sodium bicarbonate, we have the sodium carbonate, sodium bicarbonate, both are the formation by the sodium hydroxide and the H2CO3 carbonic acid. So carbonic acid itself is the weak acid. So weak acid and a strong basis, the formation of that. So if suppose sodium bicarbonate, which is one of the used ourselves, and that sodium hydrogen carbonate, sodium bicarbonate. So, if suppose that particular salt is hydrolysis there, and if suppose we have the sodium chloride hydrolysis is there, so definitely there will be the different hydrolysis procedure, and the pH value will be different because the strong and weak combination in that particular case. So let's we have to neutralization reaction. Salt is formed. This is well known, and here is greater than 7. And this is the answer. Here is the C, the blood plasma. Acids always have a pH below 7, and bases have a pH of above, while neutral compounds have a pH in the range of the 7. Hence, gastric juice, whatever the inside our stomach, gastric juice, vinegar, and lemon are the acids, so they have a pH of below 7, but plus plasma is the best. So this is the answer. So whatever we have mentioned, the number of that particular different, and finally we have the answer in our life, the acid, base, and salt, and very great color combinations, whatever these colors of we have the filter paper that will be the litmus paper, and that have the varied colors, the coloring, whatever the red is, whatever the blue is, so that can be. So anyone have any of the queries, he or she can ask me, and with my contact number as well as my email ID, and you can ask me the question related. You can share this particular video with, and so that is all about, and I am you have listening that is most acceptable by me, and hope that you get lots of information and lots of error. So that is all about. Okay, all the best. So now I close this particular specific lecture, and that is very important in our life. So all of the best wishes to all.